Okay, here's the La Pavoni with the PID controller from Auber, and you can see here the little blinking light over the AT indicates that it's in the auto program mode or the auto learn mode. I've got the temperature set for 203 as far as the target temperature goes, and then you can see it's wired up here just temporarily, and then there's a solid state relay that's wired into the PID controller. The PID controller actually turns the solid state relay on and off, and the relay of the solid state relay, or the switch I should say in the back here, provides power to the heating element. And right now the machine's running just on the high power heating element, which is 1,000 watts. So the PID controller is doing its auto learn function, which establishes the P, I, and D parameters. And then my understanding is after it completes its auto program mode, then it will flip back into its normal run mode and maintain the temperature. And if you look, I'm currently running this with a, I don't know if you can see under there, I'm currently running this with that small RTD sensor. It's I have a 1/8 brass pipe plug threaded through here, and then the RTD sensor is threaded into that. So the feedback for the PID controller is technically the temperature of that brass pipe fitting that's in the boiler, which of course, since it's in contact with the water of the boiler, should be very close to the actual temperature of the water. And we can see here, it looks like, oops, sorry about the focus there, looks like the PID controller is dropping the temperature. And you can see by this LED that's on top of the solid state relay that the heating element is currently off. So far so good. Temperature on the PID controller seems to be reading a little higher than what I think the water temperature actually is. I had a different RTD sensor, but it broke, so I'm waiting on a replacement from Auber. I happen to have the smaller one, which is currently on the machine, which I had originally ordered before I changed over to a slightly different one. Okay, it looks like the controller is allowing the temperature to drop. And since I have the set value at 203, let's just double check that real quick. You push these arrows here. Oh, I guess I can't change the set value while it's in the auto program mode. Anyways, you can kind of see how it's wired up here. Okay, I'm going to let it complete its auto program mode, and then once it starts fine-tuning the temperature, I'll flip the video back on. Okay, the PID controller just turned the heater back on via the solid state relay. It's still in the auto program mode. It's been going for about 7 or 8 minutes. And what happened was the PID controller let the temperature drop clear down to about 194. I have the set value, or the target temperature, at 203. And then when it got down to 194, it kicked on the heater for just a moment, just enough to start ramping up the temperature again, and then it cut it back off. So it appears that it's hunting around to see, based on the input of turning the heater on, what kind of response it gets as far as bumping up the temperature. So now you can see the temperature is falling again. So what it's done is, it's in the auto program mode, and what it's done is it's just injected kind of a brief amount of heating, and it seems to be now digesting what the effects of that kind of jolt of electricity or jolt of heating is, as far as the temperature curve, I guess. So now it's allowing it to fall again. Excuse me. So probably around 194, 5, 193, something like that. It'll probably do it again, I'm guessing. And I'm assuming that while it's in the programming mode, the auto programming mode, and if you look closely here, I think if we can get the focus, you can see the AT indicates that it's in the auto programming mode. Excuse me. So the temperature is still falling. Here, I'll bet here it turns on the heating element here through the solid state relay any minute. 193. Okay, well, while we're waiting, we'll take a look at my Orphan espresso cup. Doug was nice enough to send this out to me. I had to return a part about 6 months ago, and oh, here we go. Okay, so you can see it got down to 192.5 roughly, and now it's turned back on the heating element. Okay, now it's turned it off, which, since it's operating on the 1,000-watt circuit, just a brief turning the heating element on just briefly will boost the temperature up. Excuse me. So it appears that it's sorting out how long it needs to turn the heating element on in order to boost the temperature up, and I imagine it will fine-tune itself in to where it can figure out how long to turn the heating element on in order to I guess modulate the temperature right around the 203 level that I have set. Anyways, as I was saying, Doug over at Orphan Espresso was nice enough to send me this cup. I had to send a part back, and since I paid the shipping, they said they would send a cup to cover that. Anyways, it's very nice. I really like their logo. You can see the O is for Orphan and the E is for Espresso. And I'm going to use this cup here when I pull a shot on the La Pavoni here to celebrate its first shot under the PID controller. Anyways, it's still in the auto programming mode, and I'm going to turn the camera back off and let this do its thing for a while longer, and then once it gets to the point where it seems to be stabilizing the temperature around the set value of 203, then I'll turn the camera back on and record a little bit more. We'll see how it's functioning. Okay, it's come out of the auto program mode, and it's now flipping the power to the heating element on and off. So I think it's determined its PID value, I suppose. So we'll see here. You can see that it's turning the heater on and off. I think if I'm not mistaken, I seem to remember somebody saying, or I read somewhere, where it functions 25% of the time on a 2-second cycle or something along those lines. So for every 2 seconds it's on 25% of the time, which is half a second. And so you can see it's kind of zeroing in on the 203 value. So it just, now every time that little light goes on, that corresponds to the light on the solid state relay. And I think it says out here, which indicates output to the solid state relay. Okay, now you can see, oh, now it turned off. Okay, now it's getting very close to 203. So I guess what it's doing is it's kind of bumping its way up. Excuse me. And the best way to think about a PID controller is with a thermostat, when it's too cold, it turns the heating element on, and then of course a lot of heat is injected into the system, and it goes flying past the temperature you want, and then when it gets too hot it turns it off and it comes flying back past. So the analogy is like a car with an accelerator pedal that's either completely on, floored, or completely off, no gas. And imagine that you're trying to control the car at 60 miles an hour by either jamming the accelerator to the floor or taking your foot completely off the accelerator. And of course, you're going to get a very, up and down kind of rocky, experience out of that, because, every time you floor it, you're going to go zooming past 60 miles an hour, and every time you let off the accelerator, you're going to go coasting below 60 miles an hour. So the PID controller is, the analogy is using your foot to give a little bit of input into the accelerator pedal to keep the car going around 60 miles an hour. So once you get it up to 60 miles an hour, you have to give it very little gas to keep it right around that speed. Excuse me. And so the PID controller is basically doing the same thing. It's figuring out, well, once we get close to the temperature that this guy sets, how much heat or how much electricity or how long do we have to turn on the heating element to kind of stay right around where we're at. And that's what the P, I, and D variables control. And of course you can go in and fine-tune those to try to get the PID controller to function perfectly around the temperature you want. Now you can see right now it's kind of sticking around 199, even though my set temperature is 203. And we can check the set temperature here. Switch hands with the camera. If we push right here, you can see I have the set. Oops. You can see I have the set temperature at 203. Now, if I change this, like raise it up, well, push that, I can raise the temperature. I will change it to 203.5. Okay, and then once it stops flashing, after 8 seconds, it'll stop flashing, and then that will be the new target temperature. And then it's currently saying that the boiler, or the sensor on the boiler rather, is right around 200 degrees. And you can see now it's decided it's going to add some heat into the system. So now it's put some heat in, and now it's getting up there around where it wants to be. And you can see it's turned off the relay, so there's no additional heat going in. Oh, and it just gave a little bit of heat. And I don't know if you can hear on the video, but when the heating element kicks on, you can hear the water boiling inside the La Pavoni. Excuse me. So normally this is a pre-millennium La Pavoni. Normally there's just a 2-stage switch. In fact, the switch is sitting around here somewhere. Yeah. So here's the switch that normally is in the La Pavoni, and you can see there's an on-off here, and then there's a high and low, and then this high and low corresponds to the heating elements inside the machine. There's a 200 watt, and then the high one is 1000 watt. And so that's the only control you have. Basically, you heat the machine up on the high setting, which is this guy, and then once it's hot, most people just turn it down to the 1 and let it run. But the problem is the machine overheats even on the low setting. Later on, Pavoni put in a pressure stat, which would cut the power to the boiler based on the pressure inside the boiler, which I don't know how accurate that is, but I guess it's better than nothing. Of course, a PID controller is going to be much more accurate. And you can see it's zeroing in near that 203 that we've set. You can see it's getting some small pulses of heat. So it's got it zeroed in pretty well. Looks like it's giving it kind of the, every couple seconds, it's giving it half a second routine. And it looks like it's trying to stabilize around the 203.5 temperature that we've programmed in. And of course, since the RTD sensor is bolted into a brass fitting, there's going to be a little bit of a lag between the actual water temperature and the temperature of the brass fitting, but they should be very close. So you can see it's modulating the power on and off, kind of trying to target in at that 203. Anyways, this is pretty good because there's a lot more temperature control than you normally have on this machine. Now, the issue here is that at a temperature below boiling, which is for water, at sea level, it's 212 degrees. So if you want to pull your shots of espresso at a temperature of 205, the problem is that you're not going to have enough steam to force, and with no steam, you're not going to have enough pressure to force the water from the boiler up into this group head. So one of the projects I have slated here is to add a manual excuse me, to add a manual pump, so that once the water temperature is at whatever the PID controller is maintaining it at, once the temperature inside the boiler is wherever you set it, then I'm going to have a little hand pump that will allow me to quickly pressurize the boiler and then pull my shot. So we can check and see. I don't think, let me see if I can lift this up here one-handed. And there's actually a little bit of pressure. Now I don't know exactly what, let me get my, see here, I've got my little instant read. Okay, that says 168. Hang on, let me shut the camera off and grab my thermometer. Okay, I've got my instant read thermometer here. Let me put this in there. See what we've got here. Now the water is going to, of course, be lower temperature because that was the first time I ran water through the group head, so we're going to lose a lot of temperature between the boiler and the group head. But 140 degrees, it doesn't really mean anything. But it was interesting that there was pressure enough in there to pull a shot, or at least get some water into the group head. So here's the PID controller, hovering right around 203.5. And like I say, there's all kinds of parameters that you can program in, and for this particular RTD sensor, they did have some recommendations. I have them downstairs though, so I don't have them here, but I may program them in. But compared to the way the machine used to work, just turning the switch, on and off, and trying to temperature surf, or as I like to call it, temperature base jumping, because it's such a huge change. Even if this PID controller only keeps the temperature within, you know, plus or minus 3 or 4 degrees, or a few degrees. It'll be a vast improvement over what I have been using with the La Pavoni. And this is a good machine. The only problem is it's impossible to, you know, stay on top of the temperature. Usually what I do is I just turn it on, and then once it gets up to temperature, I kind of know where to turn it off and how long I have from when I turn it off to when it cools down in order to get over and pull a shot. So, but anyway, you can see it's been kind of hovering right around the 203 mark by, I don't know, I would say a degree or two for the last 5 minutes or so. And I don't know if it is continuing to learn what's going on, or if that is over and it's now kind of set its parameters. But that may be something I may have to call Auber and ask them about that. Let me see how hot this thing is. Okay, that's about 80 degrees. I don't want to electrocute myself here, but yeah, that's not very hot. That's actually almost room temperature, so I'm not too worried about the heat sink issue. I think a lot of that has to do with the fact that the 1,000-watt heater brings the machine up to temperature very quickly, and from there it's just, as you can see, it's just, well, I guess it stopped now, but as it was just doing it, it's just the cycle time and how long it's on is very small. Oh, there it goes. You can see it's every 2 seconds it's on, I think, half a second, which is what Auber mentioned one time. So, and you can see the temperatures, 203.1, 0, 29, 203, 203.5, 203.7. Now it's coming back. That's pretty good. That's basically modulating it within about a half a degree, roughly 0.6 of a degree or something like that. Yeah, that's considering that the RTD sensor is not actually submerged in the water, but just off the boiler. That's pretty impressive, I think. And like I say, it's infinitely better than what I have been dealing with as far as trying to keep the temperature in check on this. Well, just wrap up the video. I'm sure you're tired of seeing 203.5 flash by all day. As I mentioned, I'm very happy with my cup. Thank you goes out to Doug and Barb at Orphan Espresso. They've got a lot of great parts. If you're working on a La Pavoni, that's definitely the place to go for parts. You can see my naked portafilter I made here. Also got a new Reg Barber tamper. It looks like my battery's dying, but I did want to just mention thanks to roaste.com for sending out some coffee. I was on their Facebook page and won one of their little contests. So, okay, that's very, very good coffee, by the way. River's Edge, full city bold, makes a good espresso, and that's the Chesapeake Bay Roasting Company. Okay, I'm almost out of battery here, but hope you've enjoyed the PID La Pavoni video. Thanks for watching.